Hey everyone! Ever wondered how AI tackles math problems that mix numbers and diagrams? Like, how does a computer figure out the angle in a geometry puzzle? Today, we're diving into a game changer called MINT-CoT, a system that's rewriting the rules of how machines see and solve math problems. Let's break it down. Here's the catch. Traditional AI models struggle when math problems throw in diagrams. Imagine a circle with a tangent line and a question about an angle. The AI needs to see the diagram, understand the text, and connect them. But older methods, they're like trying to solve a puzzle with a magnifying glass that only shows blurry chunks. They'd crop the image into rough boxes, missing the precise lines and shapes that matter. Result: wrong answers. Big ones. Enter MINT-CoT. This isn't just another AI. It's a reasoning partner that sees the problem like you do. How? By using something called Interleave Tokens. Think of it as the AI pausing mid-thought to spotlight the exact part of the diagram it needs. Like a detective zooming in on a clue, not just scanning the whole crime scene. Here's the magic. MINT-CoT doesn't just look at images, it interleaves them with text. When solving a problem step by step, it dynamically grabs specific visual elements, a line, an angle, a point. No more guesswork. For example, if the problem mentions tangent at point C, the model highlights that exact spot on the circle. It's like having a flashlight that shines on the right details at the right time. But how does this work technically? Let's simplify. The AI splits the diagram into tiny, tokens, digital puzzle pieces. As it reads the math problem, it matches these tokens to the text. A special algorithm compares each token to the current reasoning step. If it finds a match, say, ratio in the text aligning with a section of the diagram, it includes it. This back and forth between text and visuals makes the AI's thinking explicit and accurate. Now, building this system required a massive data set, 54,000 math problems with detailed annotations. Each step of the reasoning is tied to specific visual tokens. Researchers used OCR to map text and diagrams to their locations and trained AI to link concepts like DE or BC to their visual spots. It's like teaching the model. When you see DE, look here in the diagram. The training. A three-step process. First, the AI learns pure text-based reasoning. Then, it practices blending visuals into the mix. Finally, it uses reinforcement learning to refine its choices, like a student learning from mistakes. The result? A model called MINT-CoT 7b that crushes complex problems with precision. But here's the bigger picture. This isn't just about math. It's about AI reasoning across modalities. Traditional models were like one-trick ponies. Text models read words, vision models saw images, but they never really talked to each other. Now breakthroughs like OpenAI's GPT-4o and GPT-4v are changing the game. These systems don't just process text or images separately, they merge them. Think of it like teaching a child to recognize a dog by showing them a picture, hearing the word dog, and hearing a bark all at once. The connections get stronger. The secret sauce: chain of thought reasoning. This isn't about AI guessing answers, it's about making them think like humans. For example, if you ask, what's the area of this triangle? The model doesn't just spit out a number. It breaks it down. First, I need to identify the base and height. The base is 6 units, the height is 4. Then I apply the formula, a half times 6 times 4 equals 12. It's like having a study buddy who explains every step of the process. And this isn't just theory. Researchers are building models like MINT-CoT and Math-LLaVA that combine vision and logic. Imagine a math problem with a diagram. A circle is inscribed in a square. If the square side is 10, what's the circle's area? The AI doesn't just look at the image or the text, they connect them. They reason the circle's diameter equals the square's side, so radius is 5. Area is pi or 2 equals 25 pi. It's problem solving with a side of intuition. But how do you teach a machine to think like this? The answer lies in multi-modal training. By feeding models datasets that mix images, text, and even audio, they learn to spot patterns no single modality system could catch. Think of it as giving AI a 360-degree view of the world. And when you pair that with techniques like Interleave Tokens, where models learn by weaving between text and visuals step by step, you get systems that adapt to anything, from medical scans to creative art. The results? Models like DeepSeek VL2 and MINT-CoT are crushing tasks that once seemed impossible. One study showed that adding visual projectors, special layers that process images, boosted math problem solving by 66%. It's not just about accuracy, it's about understanding. So what does this mean for you? Picture this: an AI that doesn't just recognize a cat in a photo, but can explain why it's a cat, or analyze a complex diagram and solve a math problem. This is the future of AI, where machines don't just process data, they reason with it. And MINT-CoT is leading the charge. Thanks for watching, stay curious, and let's keep pushing the boundaries of what AI can do. Outro music fades.